resistance network. It would be interesting to study the effective result when resistors are arranged in different network formation. Resistors in series. When resistors are connected one after another, they are said to be connected in series. When resistors are connected in series, the resultant value of resistance is the sum of the individual resistance values. R resultant is equal to R1 plus R2 plus R3, etc. The resultant value of resistance will always be greater than the highest value of resistance in the group. In this arrangement, the current flow through each resistor will be the same. The voltage, sum of the voltages, the sum of the voltages across resistors will be the applied voltage of the source. Resistors connected in parallel. When resistors are connected one across another, they are said to be connected in parallel. In this configuration, the reciprocal of the resultant value of resistance, that is 1 over R, is the sum of the reciprocals of individual resistances connected in parallel. That is 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3, etc. In parallel connected resistors, the resultant value is smaller than the smallest value of resistance in the group. In parallel connection, the voltage across each resistance will be the same as the applied EMF. The current through each branch of resistance would differ and decided by the ratio of applied EMF to the individual resistance value. The total current drawn from the applied source would be the sum of the resistance branch current. Voltage divider. Resistors are grouped in series to divide the source voltage into required segments. A voltage divider can be designed using 9K, 900 ohm, 90 ohm, 9 ohm and 1 ohm in series to step down the applied voltage of 10 volts to decade levels of 1 volt, 100 millivolt, 10 millivolt and 1 millivolt. This basic arrangement is an effective decade voltage divider. For 1 second, W is equal to E into I into T joules. The consideration of time taken leads to the idea of power, the rate of working or the rate at which energy is transformed. The practical unit of power is the watt. The rate of working when 1 joule of energy is transformed per second. That is W by T is the power P. Electrical power W by T is equal to E into I into T, which is equal to E into T, E into I.
is most important, vital, powerful tool for measurement, and perhaps a very good beginning for the learners to start their life with this multimeter, analog multimeter. The multimeter has got 17 positions of measurement. These measurements in DC voltages, AC voltages, DC current and resistors. Perhaps it is a very handy tool. Both can be used in a table set or can be the field use. One can use it as frequently as possible, like it is a tool, like a stethoscope for a doctor. So it is not that it is to be used today, it is to be used eternally for the electronic engineer. So the instrument, though it is a simple instrument, it is a very handy, powerful measurement instrument for the electronic engineer.